Hello everyone out there in Ivy Tech land. This is Professor Heinemann. I'm back again with our second installation of INDT 125, Introduction to the National Electric Code. Today we're talking about Article 110. Article 110, Requirements for Electrical Installations. This is a general article. It covers general requirements for the examination and approval, installation and use, access, and other things for electrical conductors and equipment, enclosures intended for entry by personnel, and other things. So it's a general application. More specific things follow in the code book. Article 110, general stuff. Okay, so I've got 19 points here I need to cover with you on Article 110. Again, it is a general guideline. Number 2, for example, one guideline is that we must use listed equipment and labeled equipment. And so we're all familiar with underwriters' laboratories and things of this nature. They serve a very useful and vital service to us as electricians and technicians and installers, that they test the equipment and they give it ratings and they approve it and so forth. And so the code indicates that the equipment that we're using must be listed, which makes perfect sense to me. Voltage rating. As you can imagine, the equipment must be rated for the nominal voltage upon which it's going to operate. So that can be anywhere from 120 volts for household current up to 480 or 600 volts for industrial applications, and sometimes much higher. Not unusual to see 4,000 volts sometimes, or 12,000 volts for some equipment in some larger installations. Now note that the code is divided into 600 volts or less and greater than 600 volts. So notice that when you read through Article 110. Article 110 covers a bit on interrupt rating and short circuit current ratings. All electrical equipment comes rated with the short circuit data. I have here a 2-pole, a double-pole circuit breaker, household variety. If you can see on there, it says 10,000. That's the short circuit rating, 10,000 amperes. If there were a short to occur in the circuit that this device is a part of, it can withstand up to 10,000 of those short circuit amperes. A little review: a short circuit is when we have a hot wire and a neutral or a ground that either touch or come close enough together to cause an arc. What we have is a dissipation, a release of electrical energy, a large quantity of electrical energy in a very, very short amount of time. The resistance goes to practically nothing. The amperage maximizes. It goes way, way up. And so it releases that energy over a very short period of time, as I said before, and causes quite a bit of danger for personnel. So the equipment all has a rating, whether it be a panel board, switchboard, switchgear, whatever it is, a motor enclosure, it all has an interrupt rating. You can check that out in more detail there. Special requirements. The book talks about special requirements. Oftentimes there will be literature that accompanies the equipment that comes from the manufacturer. Short circuit current ratings are related to this up here. What about the environment in which the equipment operates? Deteriorating agents. Are there caustic vapors or fumes? Are there other things which may deteriorate the equipment? And so the equipment, as you might have guessed by now, the conductors which are housed inside conduit and so forth, they must be rated for the environment. They must be designed for the environment. And so you can find examples of this depending on the environment in which the equipment operates. I once did a job in Chicago for a food additive manufacturer, and every single piece of equipment, electrical equipment in that facility, was made out of stainless steel. So you can imagine the expense associated with that. But reason being that they sanitized that entire facility every evening. And so it had to be able to withstand the heat from the steam washing and the pressure, as well as any corrosive materials around there. Conductor terminations are discussed in Article 110. A termination means where the wire terminates. Here I have a typical dryer outlet, or perhaps AC outlet for a household. The wires terminate here at these facilities, right here. They all have a temperature rating, they all have a withstand rating, and so there's only a certain range of wire that you can apply here. And that data is given on the equipment as well. I don't know that that's going to focus, but it's in there. You can see that writing back there tells us what we're allowed to utilize for that. Let's see what else Article 110 holds. Conductor splices. What happens if I want to join two conductors together? There's a method to the madness. There's an acceptable technique depending on the application. And so it talks about integrity, it talks about quality of work, and so forth with conductor splicing. All right, what about temperature limitations? Temperature limitations. Some environments are extremely warm, others extremely cold. And so we're asking the electrical equipment to function in those environments, and so we have to consider the temperature in which it operates. Whether it be cold, whether it be hot, we expect the equipment to perform, and so we have to make decisions as we're installing things or as we're modifying the equipment to make sure that it works like we want it to in the temperatures in which we want them to work. Okay, number 11 and number 12, arc flash information, other types of information for safety. The code goes into some detail here about that subject, although there are other portions here in the code book which give even more detail, some of the articles in the back and so forth. We have to know something about what's in the equipment. What is the potential danger? If we're going to open it when it's hot and there happens to be a short in front of my nose, what kind of danger am I facing? That's what that refers to. And so there need to be some labeling or some information of some type on the equipment that tells a qualified person what he or she can expect should there be an arc flash incident. Go to Article 100 under definitions and look up qualified person. That's important. I hesitate for a reason. Qualified person. How about 13? Disconnect means. In other words, what type of device am I using to remove the voltage from the equipment in question? They all have a rating. They all have an interrupt rating, a voltage rating, a temperature rating. They all have guidelines for terminations and other things of that nature. So keep that in mind. The code has something to say about that as well. And the available fault current is related to the arc flash information. In other words, if I have a hot wire and I join it to a ground or another hot wire without a resistance, there's a certain amount of energy which will be released during that contact. We can calculate the value of that energy, and we can figure out how big or how small the danger is. The code has something to say about the working space around the electrical equipment. You can't pile up all sorts of things in front of panel boards and switchboards and things. There has to be room for us to get in and out of there and work and open and what have you. So there's some detail in there about that. Illumination, in other words, lighting. Interestingly enough, that the code does not specify the amount of lighting required, just that it needs to be illuminated. Guarding of live parts. Okay, how do we keep ourselves away from live parts? How's that done? What techniques and what provisions are being utilized in order to do that? Keep yourself away from those live parts, preventing physical damage as well. How do we protect the equipment, whether it be motors or enclosures or switch gears or junction boxes or conduit or whatever? How do we protect it from physical damage? Article 110 will help you there. And finally, enclosure types. Enclosure types. Table 110.28, and that is in the 2014 version. My guess is it's very similar in the 2011 version. And there are a number of enclosure types for indoor use, for outdoor use, and so forth. So you can read about that. There's different examples for what the equipment might be exposed to. Okay, Article 110, a general provision for our equipment and general considerations for installations and other things. Please keep your questions and comments coming this way. This is Professor Heinemann from Region number 7 in Ivy Tech. I bid you good day.